Okay, so I'm going to do a quick video on completing the square. There's a lot of videos out there, but I'll be honest, there are a lot of step-by-step processes, and it would be really nice if there's a formula that you could just use to complete the square. So that's what I'm going to go through today. I can't find this formula anywhere. It's one that I've come up with, and I'm not going to go through the proof other than show you how to use the formula. So transforming a quadratic in general form to turning point form is realistically what we're doing in completing the square. A lot of my students don't know why they're actually completing the square, but I try to explain to them that a quadratic can take several forms. Now, we've got the general form, we've got the turning point form, we've also got the x-intercept form or the root form, but we're not going to look at that one today. When we complete the square, essentially we're taking it from a general form and we're putting it into a turning point form. It's that simple. Now, if you've forgotten your general form, here's your general form. Y equals ax squared plus bx plus c. So this is what we will be getting as a problem, and we will want to turn this form into a turning point form, which looks like this. So the way that I simplify this is completing the square is realistically taking a quadratic in the form of a general form and putting it into a turning point form like such. So how do we go about that? Quite simply, this equation here looks absolutely horrible, but I mean, if you're like me and you'd just rather remember a formula than remember all these steps that is being done in a lot of these other videos, then this is the video for you. Here's your general form, A, B's and C's. Here's your turning point form, A's, B's and C's. So it's really as simple as taking these letters C, B and A in any problem and putting those numbers in to this form over here. So we're taking it from a general form on the left and we're putting it into a turning point form on the right. You might recall that H and K represent the turning point coordinate, the XY turning point coordinate, and that's also up here. So you can actually see from the turning point form up here that H is actually represented here by the negative B on 2A value, and that K is represented by C minus B squared on 4A. So there are also little formulas themselves that you can use to quickly calculate K and calculate H. I'm not going to go through where they come from. It'll require a little bit of calculus, but maybe a later date. Here's our example, nice and quick. So we've got 6x squared plus 5x takes 7. You'll see these arrows pointing to those numbers. They're just there to show you that they represent A, B and C. A is 6, B is 5, C is negative 7. Now we're going to take this and we're going to complete the square. Okay, I know I haven't written that in the question, but that's the purpose of this video, is we're going to take a problem and complete the square. Here we have our general form to complete the square. Means we're going to be putting it into a turning point form, and it will simplify into a turning point form nicely. I just randomly made this one up. It's not out of a book or anything, and that's the beauty about this formula, is you apply it to any problem. It doesn't matter if the numbers are whole numbers, decimals, negatives, it doesn't matter. So I've simply said to solve this we're going to use the formula up here. We take our general form, which here's our example, the general form, and we transfer it into the turning point form, which is written up here. So you can see where I've got my value for B. I've substituted in a value of 5 here. Values of A are 6, which is our A value. So you can see I've just put in B is 5, A is 6, and C is negative 7, and I've substituted all those values in, and you get this nasty looking equation here. A lot of kids at this stage ask me why I put a double negative in there. It's really about being able to identify the H value. If you put a plus in there, which I absolutely agree that double negative is a positive, however, if I put a plus in there and said to someone to recognize the H value, you can imagine if there was a plus up there and not the two double minuses, if I said what's the value of H, a lot of kids would just say, oh, it's positive B on 2A, and it's actually not, it's negative B on 2A. So if you write the double negative, it allows you to see that the general form, the turning point form, when expressed with a negative, we get this negative here to equate to a positive. So it just allows my kids to see that this negative is always going to be there, because that's how the turning point form is expressed, with a negative. So whenever it's expressed such that it's x plus something, it means that H must therefore be negative. So I just do this to help my kids be able to identify that it's x minus H, therefore H is this negative B on 2A value. I know it looks silly, but it does help. So what I've done is I've substituted it into such. So you'll see I keep my double negative here. I only turn it into a positive right at the end. And the reason I keep it double negative is so that I can clearly see the h value. Once we substitute those values in, we can start simplifying, which is quite nice and easy to do for this one. You can see what I've done over here. I've simplified my 5 squared into 25 as 25 and 4 lots of 6 as 24. And then I've simplified that bracket, which, remember, this whole value here in this bracket represents the k value, which is the y turning point. So what we then get when we simplify that bracket is a negative 93 on 24. And now I've just got to simplify my double negatives and my positive negatives. So at this stage here, it is more or less done. It's just about making it look a bit prettier in terms of the double negative and the positive negative. So I then say that double negative gives me the positive, and the positive negative gives me the negative, and there we have our turning point form. You can see quite clearly a outside of x. Here's our h value, which is a negative because this is positive, and that's, as I said before, why I express it as double negative. It's just easier for me to see at this stage that value there is my h value, because it's x minus h in the turning point form, not x plus h. So it just helps you identify the h turning point. And we can also, if you want to identify the y turning point right there, which is negative 193 on 24. And as I've stated, h is negative 5 on 12, and k negative 93 on 24. If you want, you can expand this out and simplify it, and you will get back to your original general form. So that's it, guys. It's really that simple. It's just take the equation here that I've sort of simplified for everyone. As I said, it's very difficult to find this anywhere that well, from my experience anyway. So if it helps, remember this, and completing the square is as simple as writing it down and then substituting into this equation. I hope that helps, guys. It helped me a lot. But yeah, good luck.